okadaic acid, and a related compound, a very closely related compound called dinofista. Well, I think this S probably doesn't belong here. I think it should be dinofisatoxin, but this is called fiscistoxin. But in some papers, most of the papers that I've seen, it's there's only one S in here, so it's dinophysistoxin, dinofisatoxin. Anyway, these compounds, okadaic acid and the dinofisatoxin, these result eating anything that's contaminated with this, and again, these would be shellfish that would be contaminated with these things, causes something called diarrheic shellfish poisoning. This is mostly from scallops, mussels, and short-necked clams, and it causes chills, nausea, vomiting, and diarrhea. Usually not fatal, but again, something that's very, very unpleasant. And the next slide that I want to show you, and again, you'll notice that although they come from different organisms, the structures of these things are very, very closely related. And again, these have these pyrene rings, but there are not so many of them here. The tetrahydropyrenes or rings are in here, these 6-membered rings with an oxygen atom. You have it both here and here, and over here you have a 5-member, which is actually a tetrahydrofuran, and these are called spiral compounds that are actually fused at a single carbon atom. But you know, these structures, again, 2 different organisms are producing these things, but they're very, very similar in structure. Okay, this next one, saxitoxin and the goniotoxin and cylindrospermopsin. These goniotoxin comes from an organism called Goniolix, which is actually one of the bioluminescent organisms. That one does produce a red tide, a toxic red tide. You'll notice that it's very similar in structure to this other compound called saxitoxin. And saxitoxin is very, 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 very dangerous compound, producing something called paralytic shellfish poisoning. So it actually does produce a paralysis, but it starts out with a rash, a fever, usually a numbness in the mouth, drowsiness and vomiting, and then paralysis and death if enough of this material is actually ingested. So again, a very, very difficult kind of thing if human beings are actually exposed to this type of material. Actually, I want to go back a little bit. I want to go back a couple slides. There's something else I wanted to say about brevetoxin. I think it's brevetoxin. Let me just check. Because brevetoxin has also been implicated, if my memory serves me correctly, in some kind of asthma-related condition. Let me see if I can find this. Yeah, I'm pretty sure it is brevetoxin. Just bear with me for a second here. Yeah, I actually found a paper here that was published. Let's see what year. This was actually in 2005. There was a large algal bloom that occurred off of Tampa Bay, from Tampa Bay to Sanibel Island, and a whole bunch of people went to the hospital claiming that they had all kinds of respiratory distress. Some people who had asthma actually developed very, very severe asthmatic conditions as a result of exposure to the brevetoxin. So that's another thing that even though I mentioned that it was actually implicated, it's actually one of the neurotoxic shellfish poisons. It also can become airborne, and you know, that's what was happening. It wasn't just people that were eating contaminated fish or seafood, but the organism, actually the toxin, got into the air, and people that were actually breathing this in, and it was causing all kinds of lung problems. Okay, we did this slide already. Let's see. This is the saxitoxin. Okay, so I think I said what I wanted. Told you what I wanted to tell you here. And then there's another type of organism. There's another In addition to saxitoxin, there's another kind. There's also something else called anatoxin. An anatoxin, which has an entirely different structure. That's on the next slide. And there's two different kinds of anatoxins. And both of those have different structures as well. But the anatoxins also cause paralytic shellfish poisoning. So similar kinds of symptoms that you saw in the previous slide. I throw cocaine up in here only because, just to show you, because when I saw that, I said, you know, that structure reminded me of something, and I remembered that it was cocaine. And this ring system, the only difference is that this has an extra carbon in it and a double bond. But this ring system from here to here is very, very similar to what we have in anatoxin. So it's just to show you that these kinds of compounds have some kind of pharmacological activity. But this is a much different type of structure, but still considered to be one of the anatoxins. So again, a paralytic shellfish poison. And the next one I want to show you, so I think I've given you 1, 2, we've talked about, let's see, the amnesic shellfish poison, we talked about ciguatera fish poisoning, we talked about neurotoxic shellfish poisoning, and we talked about paralytic shellfish poisoning. I think those are the principal ones that I wanted to tell you about. There's another one here. Get to the next one here. Microcystin and nodularin. These are interesting compounds because unlike the other structures that I was showing you, these particular ones are actually cyclic peptides. So if you look at the structure here, you'll see that you have a carbon with a carbonyl, a C double bond O to an NH, and then you've got a couple other carbons, and you've got a C double bond O and an NH. These are peptide bonds here, where you see that. So if this were a linear structure, then we would immediately recognize that as a peptide, but it's a cyclic structure. It actually goes around and forms a ring, but it is a cyclic peptide, and as is nodularin as well. And these, both of these materials, the microcystin and the nodularin, are hepatotoxic compounds. So these materials, if you were to ingest them, these would actually produce liver damage, would cause very severe liver damage, and that's characteristic of these kinds of structures. And you'll notice again that both of these are very, very similar in structure, but they're actually isolated from different organisms. Okay, just got a couple more here. Two entirely different kinds of compounds here. Plesiotoxin and something called lingbiotoxin A. The first of these, actually both of these have similar kinds of activity, which is why I grouped them together. And these actually cause a contact dermatitis. Both of these compounds. So plesiotoxin is we say is dermatoxic, and the other one, the lingbiotoxin A, is something that it causes something called seaweed dermatitis, and the other property that lingbiotoxin A has is actually, it's also known to be a tumor promoter. So these again would be dangerous kinds of compounds. So I just wanted to give you a feel for some of the kinds of chemical species, a variety of different kinds of chemical compounds that are actually isolated from these two classes of organisms, the dinoflagellates and the cyanobacteria. And so we have to be very cognizant when we eat, if we are going to eat fish that are swimming in waters that might be contaminated by some of these organisms. We're obviously not worried about shellfish, but other people should be worried about shellfish. But even it's not so much of an issue. It's not so much of an issue where we are here, but it's much more of an issue if you were in those of you that might be living further south. If anybody's in the Florida area, there'd be much more of a concern for those kinds of conditions to occur, where you actually could get a red tide, an algal bloom. So anyway, again, we're going to have the same format that we've had in the past: 25 questions on this from the chapter, and then probably about 8 from the lecture as usual. And next week we'll be talking about deep. That will be chapter 16, and that's the deep sea organisms, deep sea fish, etc. And I think we have, after that, we have only, I believe, 2 more lectures beyond that. So again, I hope to see everybody or talk to everybody again next week, and I wish you all luck on the exams. Thank you.